So the number of subintervals are denoted by n, lowercase n. In our first case, n was 2. But now let's say n equals 4. So this is 0.5 and this is 1.5. Let's do just one. A left with 4 subintervals. Height, 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 height. Base, 0.5. That's not good. Base, 0.5 times f of 0 plus base 0.5 times f of 0.5 plus base 0.5 times f of 1 plus base 0.5 times f of 1.5. Careful, if it says 4, you have to have only 4 products. Okay, you cannot move on to the next one. It has to be 4. Okay. Of course, you see 0.5 is the same, so I'm going to put it out. F of 0 for our function, f of x equals x squared plus 1. F of 0 is still 1. F of 0.5, 0.25 plus 1, 1.25 plus f of 1 is 2 plus 1.5, so this is 2.25, 3.25. So I got 3, that's 7, 1, 2, so 4, 3, 7, so 0.5 times 7.5. 3.55. As expected, somewhere between 3 and 7. Question now. What if I say, oh, let me ask you first question. Do you think that the estimate with 2 subintervals is better or worse than the estimate with 4 subintervals? Which one is better?
The one with 4.
Exactly. Excellent. Now, what if I say n equals 8, and then I say n equals 16, or n equals 64, or n equals whatever? Which of these will be better?
The more, the better.
Excellent. When we say the more, the better, we studied something very important in this class. Where have we seen something like this? In connection to what?
Limits.
Absolutely true. Limits. So the limit as n approaches infinity from, I'm going to write it in words first, sum of areas of rectangles. So coming back here, base times height plus base times height plus base times height plus base times height. These are areas of rectangles. Sum of areas of rectangles. Sn, which is number of subintervals, goes to infinity. What do you think this will equal to? It will be approximately the area, or it will be the exact area? It will be the exact area. The absolute exact area. This has a name. I do this extensively with my STEM class. We don't have to do it here, but I just need to explain what it is. So this is called the Riemann sum. This mathematician came up with how to calculate. We don't have to do this. I'm not gonna, it's very detailed. I can, but it's not required in your class. So the limit as the number of subintervals goes to infinity from the Riemann sum will be the exact area, guaranteed. Okay, so let's look at, where's my book? I know we have 5 minutes left, even if we just start. So I'm on page 401. So now, a little bit you understand what I said at the beginning with this. A little bit you understand this. Where does this come from? Base times height. This is the function. Plus sum. Plus base times height, the function. Plus base times height. And this is the sum. The sum is the sum of the areas of rectangles. That's why we use S stretched, because it's easier to put in the stretched S the function and dx. That's the only reason. And now you kind of understand where that S is coming from. It's a sum of areas. Okay. So they are directly going into something else which I don't want to talk about yet. We are not ready for that yet. We have to calculate at least a couple of areas to see what this works. Okay, so let's choose any graph. We're going to start it. We're not going to finish it. We'll finish it on Thursday, but at least let's choose a graph. So let's say 19. They are graphing for us 1 over x squared. Awesome, thank you very much. And over the interval 1, 7. Thank you again. Now, please look at this graph and identify, is it using the leftmost point for these 7 intervals, or is it using the rightmost point for these intervals? For these 7 intervals, subintervals. Is it the leftmost point or is it the rightmost point? Okay, so follow the mouse. Up, left, right, down. Up, right, down. Up, right, down. Up, right, down. Is it using the leftmost point or the rightmost point?
Left.
Exactly. It is using the leftmost point because it starts with the height hitting the function and going to the right. And then so on and so forth. So if we want to just look at 19a, first of all, the area will be approximately, it's left 7. I like to write it like this. You can write it in other ways, I'm fine. So the area using the leftmost point and 7 subintervals. Now, I would like to pull out the width of the interval, which is the same. So what is the width of the interval? So I can pull it out. How wide is each rectangle?
1.
Exactly. So, of course, I will have 1 times. And I will not calculate. I just want you to tell me what it is. I will have to write, what is the height for the first rectangle? F of,
F1.
exactly, plus the height of the second rectangle. What is it? F of? Yes, f of 2. What is the height of the next one? F of 3 plus f of 4 plus f of 5 plus f of 6. We have to have 1, 2, 3, 4, 5, 6 subintervals. And I have to stop. And we'll calculate them on Thursday.